Alrighty, in this video we are going to be talking about logarithmic differentiation and taking derivatives with logs. We already know how to take the derivative of ln, so that's good. And then here we're just going to take the derivatives of logs. And then on the second video, I'll talk about how to take the integral of logs and ln's. But I mean, as a review here, not that much. Remember that the natural log function is going to be f of x is equal to ln of x. So that means that f prime of x is going to be 1 over x. Remember, that's going to be your basic function. However, sometimes your x is going to be a function. So on the inside, it's going to be a function. You're going to have to use chain. So if you're using chain, and let's say that you have a function g of x, then you're going to have 1 over g of x, and then g prime of x. And then your integral, remember that's just 1 over u du, and that's going to give you ln of absolute value of u plus your constant of integration, whatever that is. Now, your new thing, though, is going to be your log function. Your derivative here, if you have log base a of b, f prime of x is going to be 1 over b ln of a. Given that you have an a here, and then this is your function. Or x. Let me put that as an x. There. 1 over x times ln of a. Now, obviously, you're not going to have x all the time. You might have some function. So once again, let's pretend that this is a chain. So then you're going to have 1 over your chain, so 1 over g of x, times ln of a, that stays the same, and then g prime of x, whatever that is. So your integral here of 1 over x ln of a will give you log a of, not b, but x plus c. Oops, don't forget about the dx. Yeah, and let me put this in x2. Now, of course, if this isn't an x, and let's say it's g of x, then remember that you're going to have to use substitution to make it look like this basic integral right here. In addition to that, make sure that you remember your properties of logs back in Math 3 and in pre-calc. So thinking about these, if you have product, remember that if you add your logs, you can condense them into one log by multiplying them. If you subtract logs, you can condense them down by dividing them. We're going to use power the most. So if you have a power right here, that can be simplified by taking the b and your exponent as your coefficient now. And then change of base, just in case you need it. For my 83 people, so you have log of b over log of a. So for number 1, it tells you to use properties of logs to simplify f of x is equal to ln of the square root of x minus 1, and we want to use that to find f prime of x. So we are going to use properties of logs. So the first thing that I'm going to do is go ahead and put this in exponential form. Once I do that, I am going to put the 1/2 up front as a coefficient to get 1/2 times ln of x minus 1. Once I do that, I could take the derivative of 1/2 ln of x minus 1 pretty easily, because we know how to take the derivatives of ln's by now, hopefully. So f prime of x is going to give us 1/2 of x minus 1. Ta-da. Okay, so for number 2, you want to find y prime using log differentiation. So we have y is equal to the square root of x squared minus 1 over x squared plus 1. here's the thing about this one. If I were to take this derivative right here, I'm going to have a couple of things. I'm going to have to use chain, and I'm going to have to use quotient, because this is a function within a function, because this is raised to the 1/2. And then since this is division, I have to use quotient. This is going to get messy pretty quickly, because I'm going to have 1/2 x squared minus 1, x squared plus 1, negative 1/2. And then I got to take the derivative again in terms of quotient. And that's going to be a mess. So instead, we're going to use log differentiation. So what does that mean? We're going to take the ln of both sides. And the reason why is because taking derivatives of ln's are pretty easily. And if we do it on both sides, it's essentially equivalent to each other. So now I have ln of y is equal to ln of x squared minus 1 over x squared plus 1 to the 1/2. Go ahead and simplify that for me. So what I did here was bring down the 1/2 as a coefficient, and then I expanded my natural log on the right side so that I have ln of x squared minus 1 minus ln of x squared plus 1. Once I do that, I'm going to take the derivative of the left side and the right side. On the left side, pay careful attention. We want to take the derivative with respect to x, so you are going to use implicit here. So you're going to have 1 over y dy dx is equal to 1/2, and then taking the ln, the derivative of ln is pretty easy, hopefully. So you have 1 over x squared minus 1 times the derivative of x squared minus 1, which is 2x, minus 1 over x squared plus 1 times 2x, and then you have that. Okay, so now I'm going to multiply by y, because I want to dy dx. So I'm going to have y over 2, and then 2x over x squared minus 1, minus 2x, x squared plus 1. I could probably simplify the 2 out and cancel them out. Let's get this right here. Now, one important thing to note is that even though you have a y in your answer, that's okay. However, this isn't an implicit function. As you notice here, y is being solved for x. So this isn't implicit. This is actually an explicit, because you actually know what y is. Because you actually know what y is, you're going to have to substitute that back into your derivative, just in case on the multiple choice section you don't see a y in your answer. And if you don't, then it's because y is already solved for you, and you just substitute that back in. So your answer is either going to look like this if you have y, or it's going to look like this if it's on the multiple choice, and it requires you to simplify all the way so that you don't see any y's. For my sake, go ahead and substitute it in, just because it's an explicit function and you already know what y is. Later on down the road, whenever we talk about something like number 8 right here, whenever it says use implicit, then you could just not solve for y, because we're using implicit. Okay, so that's your final answer for 2. Number 3, we're doing the same thing. So we want to find y prime. If I were to take the derivative here without using logarithmic differentiation, you're going to have to use chain again, and then you're going to have to use product. The problem about this is that we don't know how to take the product of 3 products, or the derivative of 3 products. You're either going to have to multiply it out to get 2 products, or multiply it out again so that it's simplified on the inside. That's going to be too much work, whenever we could just take the ln of both sides. So for number 3, I'm going to take the ln of both sides, And at this point, hopefully you didn't do this separate here, because honestly, you should know that the square root is going to be 1/2, and then that 1/2 can be taken up front. And then, since this is all multiplication, you're going to use your product property, and you are going to expand that so that it looks like this right here, using your little expansion. Once you do that, you are going to take the derivative now with respect to x. So you're going to have to use implicit here. That's going to be 1/y dy dx is equal to 1/2. And then the derivative of these are pretty easy. And then solve for dy dx. So that means multiplying by y. And because y is already solved for us, you are going to go ahead and substitute this right here into the derivative in your final answer. So dy dx is equal to that lovely thing divided by 2 times this lovely thing that we found right here. All right, so for number 4, this is a log differentiation, and that is what we did right here. So what you're going to do is do 1 over whatever your inside function is. So that's going to be 3x squared. And then we are going to have ln of whatever your base is, in this case 3. And then we're going to take the derivative of your inside function. So that's going to be 6x. Honestly, hopefully you could clean this up a little bit with the 6x over 3x squared. So you're going to get 2 over x ln of 3. Number 5, it's essentially the same thing. So you're going to have 1 over your inside function. And whenever I mean inside function, I mean the whole thing, including the 5 as your exponent. And then ln of whatever your base is. In this case, it's 3. And then I'm going to use chain to take the derivative of that. Keep it like this unsimplified. That's fine. I'll be happy. If you were to simplify this, you're going to get 75x to the 4th over ln of 3 times 3x to the 5th plus 5. And remember, of course, if you already have this, just keep it like this, unless it's a multiple choice question where it gives you the simplified version. So you might need this just in case it's on the MCQ and it's all simplified. Okay, for number 6, I'm going to take the ln right here, and I'm going to expand it. Now notice how here, I did not take the ln of both sides because ln was already given to us, so I could already expand the right side. You don't have to take the ln of both sides anymore because obviously ln's right here. It's already given to us. Whereas for number 2 and number 3 right here, ln was not given to us, so we had to take the ln of both sides in order to differentiate. So here, we have y is equal to ln of x minus ln of x plus 1. So I have y prime is equal to 1 over x minus 1 over x plus 1. And that's it. You can simplify this. I'm choosing not to. There it is. All right, what I want you guys to do is pause the video, okay? Do number 7. Even though it looks scary, it's not. Use your expansions from Math 3. I know you guys can do this. And then click play once you're done. Oh, well, let me actually expand this first. The numerator is going to be a plus. And then your denominator, since it's division, you're going to subtract. So you get this right here. Oops, forgot the ln. Okay, take the derivative. Ln of x, 1 over x. Ln of x squared plus 1 is x squared plus 1 times 2x. And then ln of 2x squared minus 1 is 1 over 2x squared minus 1 times 4x. Clean this up a little bit. It's an easy cleanup, hopefully. You don't do something stupid. But if you're scared that you are going to do something stupid, then just keep it like this right here. That's okay. Oops. So this is going to be your final answer. All right, so for number 8, I told you guys earlier that we're going to be using implicit, and since nothing's solved for y, you could leave whatever your answer is in terms of y and x, just because I don't know what y actually is. So here, once again, don't use chain here and product. Instead, go ahead and simplify this by expanding it. It's going to be the easiest way for you guys to do these types of problems, by expanding ln and then taking the derivative with respect to x. So I have 1 over x plus 1 over y dy dx plus 5 is equal to 0. We are going to solve for dy dx. So this is going to give me 1 over y. Dy dx is equal to negative 1 over x minus 5. Multiplied by y, so you're going to get dy dx is equal to y 1 over x, negative 1 over x minus 5. This right here is your answer. It's okay to have y just because it is implicit. Okay, so for number 9, we have ln of the absolute value of cosine. So here, we have ln of the derivative, the ln of stuff, so 1 over cosine. And then we take the derivative of that, which is negative sine. And then if you were to do that, eventually you'll see that you have negative sine over cosine, so that's going to be negative cotangent. All right, we are going to do 10 through 18 in another video, but the first 9 problems were on differentiation.